We go to number 3.
So use the normal probability app. Oh man.
I have to find it again.
Yep. Nope, that wasn't it. Have you found it?
I think it's in lesson 5, but I haven't found it yet.
Wait, which one does it want?
The normal probability one. So I guess I don't know which one. Oh yeah, it's in lesson 5.
Oh, okay. So lesson 5. Is it under the individual preparation? The link or whatever?
I don't know if it's on iLearn. I just in the textbook. It was.
Oh. All right. Was there a link to get to that?
Yeah, if you go to chapter 5 in the book and scroll down, there's a spot where it you can actually use it on there. But then there's a link that you can open. Also.
Oh, yeah.
Did you get it?
I did. Thank you. All right, so back to all right. So use the normal probability output to find the combined area under the standard normal curve. Is this just like a review?
It might be. I don't know.
All right. Give me 1 second. I gotta get my stuff. No, hey. Just cut your hair. I would do. Okay, sorry.
Okay.
So, did you
So the
figure it
first one,
out?
you just plug in the z-score, or the z equals to each one,
Mm-hmm.
and then find underneath just in between the lines.
So it's, what was it, negative 1.38 or something?
358.
No. Mm-hmm. And then it wants the middle.
Yeah.
So remind me, do we shade the middle? And
Yeah, shade the middle, and then, or shade it, and then the sides aren't shaded.
so it's 0.825
Yeah, but it would be 0.826.
because rounding. Okay. Square assumes the mean. Okay, so
So I think this one's the one where we find like the mean of the random variable and then the standard deviation and plug them in. But I'm not
into
sure.
that one thing, right?
Yeah. So the mean of the random variable is u.
Mm-hmm.
So
Because the mean,
it would be 177.6, right?
yes.
And then
Wait, wouldn't we just want to find the z-scores for these?
maybe. Yeah, I guess that would work if we found the z-score.
Because we have the mean.
So the z-score would be the value minus the mean, and then divide by the standard deviation.
Yes. But I guess we can't do it because we don't have the value, huh?
Um, would the sample mean? I don't know.
No. So the mean actually is 185. And then the sample mean is 177.
0.6. Yeah.
Not exactly sure how to find this.
Okay. So maybe I think the sample mean minus the mean weight of the passengers.
Okay.
Okay, let me look at paper.
Yeah, so it wants us to find the standard deviations. Or I mean the z-scores. So that we can plug in and find the probability. That's what this lesson was about. Or this review.
One second. Okay. So
But would it be 48 is the value?
that's what I'm kind of thinking.
Because if that was it, then it'd be 48 minus 185 over 26.7, which then we'd get which you get a pretty big number. I got negative 5.131.
Okay.
Which that doesn't sound right.
I wonder if the down below it'll tell us. So it says, suppose that a sample size of n equals 4 has been drawn from a normal population. So the mean is 7, and the standard deviation is 3.
Where are you reading from?
Right down below, this says 2, or the section 2 on lesson 7. And then it says worked example. And so it gave us that. And then it says since the parent population is normal, we know the sampling distribution of the sample mean x will be normal and mean u equals 7. That gives you the standard deviation. So for that, I don't know where they got 10 from though. But for the standard deviation, they did the standard deviation over the square root of the size.
Okay.
So for us, the standard deviation would be...
It's 26.7.
26.7, and then divided by the square root of 48.
And that gives you what though?
That gives you...
That gives you...
It's like the bottom part of the z-score. So it's like the standard deviation of the z-score.
Okay. Got it. Hmm.
Okay. The only thing is I don't really know where they got 10 from. But I think that might be like the normal, like the mean weight, and then ours is the sample weight. So I think you just do the mean weight minus the sample weight.
Right. Hold on.
And so then you have that, and then you divide it by the standard deviation that we just found.
Mm-hmm.
And then I think that gives you your z-score.
Ah. Okay. Okay. I'm following you.
Yeah.
Alrighty. So first, yeah, I don't know why I was so lost there for a second.
I was too. So
26.7 over 48, right? Is our, yeah.
yeah,
What's the square root of 48?
it's like 6.9.
Okay.
Let's see. Oh, wait, yeah.
Divided by, where are you? Square root. You kidding me? Well, my calculator doesn't have, well, my phone doesn't have square root.
Oh, well, okay. I'll just tell you what I got then. For the z-score, I got 1.920.
Okay. And so,
And then since it wants the extremes, we'll put that in for our z-score, and then we'll do the outsides of the lines.
yep. So did you get 0.0549?
Yeah.
So rounding 0.05, what was it?
0.55.
Alright. Which of the following has smaller standard deviation if 9 observations are randomly drawn from a population? Standard deviation will be smaller if, I don't know if we can actually determine that.
I know, I don't. So which of the following? Okay. So for the one above, we had a smaller standard deviation.
Mm-hmm.
But I don't know whether or not that would always be the case.
Yeah, I don't know.
Yeah. I know, I think you might, because you take and always divide, you have like your standard deviation and then you divide it by the square root of observations.
Right.
So if you have only 9, then it's going to be
Small.
smaller, I think.
That makes sense. So it'd be the distribution of it in a sample means? Because that's what we were finding there, wasn't it? In 4?
Oh, yeah. Yeah, so yeah. Do you know what X is?
X with the line over it?
Yeah.
The mean,
Okay, yeah.
I think.
I think you're right.
Yeah. So it's not the rule of 68, 90, whatever that is.
Yeah.
It's not going to be a normal distribution. Law of large numbers.
I don't really remember what everything is.
Well, let's find out.
Yeah. So, okay, the distribution of sample means is normal when X is normally distributed or when our sample size is large because of the central limit theorem.
Okay.
But then the law of large numbers states that the sample size gets larger, the sample mean will get closer to the population mean. So I think it might be law of large numbers.
That's what I was thinking. Scores on the quantitative portion of the GRE. Okay. So Diana earned a score of 160 in the quantitative portion of the GRE. What is the z-score corresponding to Diane's score? Round your number to the decimal. It's just your mean over your... Oh wait, no, you have to find z-score. Duh. It's her number minus the mean over the standard deviation. So what'd she get?
Yeah, so she got 160.
160 minus 150.8 over 0.8. Mm-hmm. 1.045.
I haven't done it yet. So, yeah, I think you're right.
Okay. What is the probability that a randomly selected student will score above 160 on the test?
What did you get for the z-score?
1.045.
Okay, yeah.
So wait. Oh, above. So we can just put that in the app in the thing, right?
Yeah, I think.
Um,
If 160 would be in the middle, right?
yes.
Okay, so you have to move the lines so that they're in the middle and then do the above.
Hmm.
Maybe not.
Um.
I was looking at the z-score and they change when you move the lines.
Yeah.
So maybe it's just above the last line? Yeah, because that would have been her z-score.
Yeah. So if we put it right, what was it? 1.045. So it's what, 14%
Yeah.
or 15 for where we have to round?
Yeah, but it's not asking for percent, so it would be
Point.
0.148 because it's 3 decimal places.
Yep. A random sample of 5 students was selected to take that test. Their scores are that. What is the z-score corresponding to the sample mean of these students? So we need to find the sample mean first.
Yeah.
How do you find sample mean again? Do you just add them up?
So yeah, and then divide by however many.
What chapter is that in? 5?
Is what?
The
The applet?
no, like how you find sample means.
I don't remember. But I know how to find the mean, you add them and then divide them.
Mm-hmm.
And that would be the sample mean, not the whole mean, because you're only doing it for what you
Oh,
had for the sample.
that makes sense. Okay.
So I got 160 as the mean.
Okay. And that's the sample mean, right?
Yeah.
Okay. And if we want to find the z-score of that,
Mm,
so would we just take 160 minus the mean over the standard deviation?
yeah. Wouldn't it give us the same? Oh no, it'll give us a different one than the one before. Because before we only had one person.
So it's the standard deviation over 5. What? Wait.
Hmm. Do you remember how to find the standard deviation?
For sample mean?
Just like the standard deviation.
So it's x minus the mean over over the standard deviation. That's how you
Oh
find.
yeah, we
Wait,
have the regular standard deviation. Never mind.
yeah. So to find, so it says so the standard deviation of sample means it's the standard deviation over your n squared.
Okay.
So that's going to be the 8.8 over square root of 5.
Yeah.
And that'll be our z-score.
And then 160 divided by that, right?
I actually don't know.
Well, that gives us a really big number, so I'm not sure either.
What is the, if you
Oh
just
wait,
do,
no. It's 9.2 over that, I think.
that makes sense.
Okay, yeah, so like 1.478.
Perfect.
That's what I got.
And what is the probability that 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous problem? So you just put that in there. 1.478. Not a very high chance. So did you get 0.0697?
Yeah.
All right. So, the mean GPA of BYU Idaho students is 3.5. That's pretty good.
Yeah.
Standard deviation is 0.7. Okay. What is the shape of sample distribution of the random variable x, which represents the sample mean of 81 students who were selected? Normal. Right? I'd assume it's normal.
Yeah, I think it probably would be approximately normal.
Well, what? What is the mean of the distribution of the sample means for all possible samples of size 81? So just standard deviation over the square root of 81. I get your z-score, wouldn't it? Nope, I get your standard deviation.
Yeah. Is that what it's asking for, is for the z-score?
Well, it wants the mean.
Oh, okay, yeah.
The mean of the distribution. Ugh. Hate this. The sampling distribution of the sample mean is a set of all possible values of x that could occur.
So on here it says the mean of distribution of sample means is the population mean U.
Population mean U?
Yeah. That's what it said.
Okay. So
Well, I thought that was going to give us the answer, but
what? Is that really that easy? So it says that the mean of the sample mean is the mean.
oh,
And then the
okay.
standard deviation of sample means is the standard deviation over your population, your n,
Oh.
whatever.
Well, that works then.
Yeah. So
it'd just be 0.7.
0.7.
Wait, it's no, because it's the mean is just like the mean of it, right? So it'd be 3.5.
Wait, what?
So the mean
Oh, it's
of
3.
the distribution is just the mean, right?
Yeah, 3.5. Yeah. What is the standard deviation of the samples distribution of the random variable, the mean of the 81 who was selected? So I think that that's the standard deviation over over n, the square root of n.
Oh. Okay. So over 9.
Mm-hmm.
I think you're right, yeah.
So it's like 0.078.
Yeah.
Or 778. What is the probability that the mean GPA for 81 random selected students will be less than 3.5? How do we do that one in 10? So you found the z-score of the sample, and then we plug it in. So we need to find a z-score.
I think so, yeah. So then would we just do 3.5 divided by 0.0778?
Say that again. Sorry.
Would we just do 3.5 divided by 0.0778?
No, because we want to find the z-score specifically for the 0.3. I mean, yeah, the 0.3. So I think we just have to do the 0.3 minus 3.5 over the standard deviation.
Oh, it does. Oh, okay.
And then we just plug that in, and then we use the applet to find the percent, I think.
Okay. I'll definitely have to review before the test next week.
Yeah, seriously. When is that test open, by the way?
I don't know. I haven't looked at that yet.
So equals negative 0.286. Is that what you got?
Yeah.
And then we want it for the lower half, right?
Yeah.
So 0.387.
Mhm.
And then it wants just for the ones above.
Yeah.
Should be the same. Oh, wait. I lied. 6,612 or 613.
Yeah. Alright.
Moment of truth.
Okay.
What?
What was that?
Oh boy. Well, we did okay on some.
I know. Yeah.
At least it tells you how to do it.
Yeah, that's nice.
The z-score for mean is given by z equals. Oh.
Huh.
So we did pretty much, what was it, 14? I'm looking at 14 right now. We did
Oh,
that,
yeah.
except the only thing that we did wrong was apparently you have to put the number. So it's like, did you see that? Like the 81 square root of? Square root
Yeah.
of 81. That's the only thing I think we did wrong. I didn't know you had to add that.
Thank you.
And if we got that, then it would have been.
Yeah, then we
would've
would have
gotten
gotten the
15.
other one. Right?
I'm gonna write that down though.
Let's see.
Okay, so z score for a mean of whatever. Okay, that's good to know. Actually, x minus the u
I think we just did it wrong.
divided by. Yeah, I had the wrong formula. I didn't know to find the z score you had to have that the standard deviation divided by the square root of n over. I didn't know you had to have that. I thought you just needed the standard deviation.
Yeah, I don't know. I kind of got confused on like what the standard deviation was and what the other like standard deviation was, but
Yeah. Well, that's what this is for.
Yeah.
And then do we do the same thing in? Yeah. Do we do the same thing in 9?
Yeah. Yeah. So, well, now you know.
Yep.
All right. We'll see ya on Tuesday at 4:30.
Sounds good to me.
I think. I think we have to meet next week. I don't know.
All right.
All right. Bye.
Bye.